Hi, I'm Simon Langley, Managing Director at Aqua Services. Thank you for the opportunity to share with Water Test Network members Aqua's AquaPyr Ultra-Low Waste Filter. So what I'm going to cover in today's presentation is an overview of the Ultra-Low Waste Filter, the trial setup from our Bonus trial in terms of the objectives we set out with and how we arranged the site, a snapshot of the results covering effluent quality in terms of total suspended solids, the waste volumes generated and the power including the micro renewables that we consumed and ran on during the trial, an overview of the achievement of our objectives and how we found the water test network process. So what is our Aqua Ultra-Low Waste Filter? It's an air-cleaned cloth filter which produces 10 times less waste than water-cleaned filters. Flow is out to in. It's a cloth that's submerged to 85% depth in the filter tank, and it's of a 10 micron pile knit consistency. Solids captured on the cloth during filtering are vacuumed from the non-submerged cloth area, and the solids removed during that clean go into a waste tank and are then pumped out. The cleans are always initiated either by level or timer, and the solids are transferred after each clean. The great features of the unit are, as well as its air-cleaned low waste volumes that it produces, we have ability to double clean, which is known as deep clean, to forward and reverse clean, which extends cloth life, and we have an optional chemical clean in place if needed. The picture to the right shows how the unit is arranged, with the feed coming into the left of the unit and exiting at the bottom right. The filter drum through which the solids are removed, and the vacuum blower that creates the vacuum to suck off the cloth and deposit into the sludge chamber at the back. The model we used at Bonus was the Model 25 and has a design flow rate of up to 5 cubic meters an hour, dependent on solid load. So the objectives we set out with the trial were to confirm reliable operation, to demonstrate the effluent quality on both final and primary effluents using two 10 micron cloth variants, ideally aiming to achieve less than 10 mg a litre on final effluent. This, Severn Trent have told us, is the key to meeting future low peak consents when combined with either ferric or alum dosing, an algal treatment or electrocoagulation. Another objective was to demonstrate the waste volumes and the percentage dry solids to back up our claim that this is an ultra-low waste filter, and to confirm the power requirements for the unit. Again, this is a low power consuming unit and also to run on zero carbon micro renewables. All of the samples conducted during the trial were taken by Scottish Water and analysed at their accredited lab. These are the photos, the sort of images, and the key are down the left. Key ones to look at here: the filter in image 4, the micro renewable pack in image 7, and the waste pump and vacuum blower in image 6. So results we achieved during the trial. This is a snapshot from cloth 1 on final effluent. We always achieved total suspended solids or TSS of less than 8 mg a litre, which compared to the 10 mg a litre target we were looking for was a great result. The average was 5.5, and that was against a peak solids loading of 0.2 kilograms per metre squared per hour. We ran at different flow rates of 1 up to 2.5 and up to 3.5 cube an hour. Same cloth but on settled primary effluent, again same flow basis. We achieved an average of 42% total suspended solids removal at a solid loading rate of 0.42 kilograms per metre squared an hour. That's in line with the sort of peak we'd expect the machine to be designed for. In terms of average waste volumes, each base clean typically produced 4 to 6 litres of volume. On final effluent, the waste volume was less than 0.8% of feed flow, on primary less than 1%. The composition was 0.26% dry solids on final effluent and 0.5% dry solids on primary. In terms of the power, we ran successfully off the hybrid off-grid renewables installation that we put into the trial, and this was an inverter, 2 solar panels, a wind turbine and a battery bank. We measured the power consumed by the unit that was powered from this renewables, which was 0.64 kilowatt hours a day, against a calculated theoretical from the design of 0.62, so a very close approximation. What that meant was the objectives we set out with in the trial were really met. We had a stable, simple operation, and it was robust, the filter under lots of different feed conditions, with only a limited number of screens in the HMI to operate. The effluent quality was excellent, and means that we'll meet low P in the future with this unit. The waste volumes were in line with design, which is roughly 10 times less than a water clean filter, and the unit ran on the micro renewables pack, helping achieve zero carbon targets of water companies. How did we find the water test network process? Well, the application process, the two-stage process, was really simple, straightforward and effective, and we were really well supported by the Scottish Water Horizons team guiding us through the process. The requirements were clear and really well laid out. Other things we did, we really planned the trial out well with Scottish Water Horizons, including training them to operate the unit remotely prior to arriving at site. We also did a pre-start meeting to look at the interfaces, and that helped remove risks from the trial. We had regular trial catch-ups at site to ensure smooth running, to discuss observations and to host visits. And we're here today looking at a post-trial push to making sure we remain in contact and seeking that next opportunity for an extended trial to really add value to the work done from the Scottish Water Test and through the Water Test Network. Any questions?